graphics cards in. So you can plug things like NVIDIA's M10 and NVIDIA's M60 cards into them to provide graphics acceleration for the stack. They also scale extremely well on memory, up to, I believe, it's 768 gigs. But the final little tidbit that I'll point out, and this is a very unique element to Cisco that differs from others, is their architecture allows you to scale out the compute independent of the storage. So a lot of other platforms, when you add another node to a cluster, you're adding additional storage, compute, and memory, right? All three of those core components. In a UCS-based hyperconverged system, you can pair their B-series, their Blade series servers without any local storage into a cluster, utilize the HyperFlex cluster itself to deliver storage to the rest. So it's kind of a unique and independent value proposition. Third reason I'll highlight here is that this stuff is production ready out of the box. So I mentioned they do a great job on the simplification story, right? And I'll tell you right up front, I'm not a guy that likes data storage. I hate dealing with SANs. I hate dealing with fiber channels and mapping my WWNs and all that kind of crap, figuring out my RAID array levels and disk groupings. All that complexity just completely disappears when you leverage something like HyperFlex underneath Citrix. So right out of the box, from the baseline installer, you gather a few bits of data about your IP addresses, naming, resources you're going to connect to, administrative passwords, credentials, and stuff like that. You plug them into their web-based wizard, you hit go, come back a half an hour later, look, it's there, it's done. Run a quick post-install script, and what comes out the other end is a production-ready, very, very solid, highly available bit of infrastructure. So that includes an A-side, B-side architecture. So you've got full redundancy throughout the network fabric as well as the physical servers themselves. And it gets clear down into the stack, so they configure the virtual interfaces on the servers. So you've got your storage network, you got your management network, you got your VM networks, you got your out-of-band network. So all that stuff is just configured nice and tightly for you right up front. And there's literally, to jump in and start using it in a productive manner, including things like vSphere, HA, and DRS. Those things are also set up and configured for you right out of the box. So it's a really nice configuration with a one-click upgrade if you need to do an upgrade on the storage layer itself. Last reason I'll point out is that the stuff just plain works. So I think I probably have hammered home this idea of simplicity and the fact that this goes through. So what I've done is a little bit unique in, I've spun up a couple of community projects under the umbrella of Project Silverton. I've shared with you a blog link here that you can go out and take a look at. The two first projects that we've done some pretty extensive write-ups on cover hands-on with HyperFlex. So that's a colleague of mine that sat down, went through the install configuration process, wrote it up from his perspective, not from a Cisco perspective, and shared that with the community through the Citrix user group community site. Second project is one I'm in the middle of, and I've been really deep into this one. And that's running a combination of a network workload and a desktop workload on the same cluster. So what I'm doing inside of that project is really going and looking at measuring the impact of running a desktop workload alongside a networking workload in the form of our NetScaler VPX appliances. Running those things side by side. So you got one bit of top-tier infrastructure that handles all the bits that you need of infrastructure to run an app and desktop-based workload. So I'm not going to dive into all the details. There's massive, massive nitty-gritty details if you go scope out those blogs. But long story short, HyperFlex doesn't really care about the networking workload running on top of it. It's just a minor blip. So I don't have it boiled down to the actual percentages of cluster-wide CPU and memory utilization yet. That's coming in the next round of the series. But suffice it to say, what a lot of people have been doing anyway, running their VPXs on the same infrastructure that they run their desktop and app workloads, I have not found a single thing yet in my completely anal and deep digging in to try and prove it one way or another. I haven't found anything yet that has given me any indication that this is a bad thing to do. So we'll see where that comes out at the end. So the last bit that I'll point out on this is even with this cluster, so this cluster, the specific physical cluster that I've been testing on, is actually older class CPUs. It's V3 Xeon CPUs versus the V4s. It's light on cores, 8 core per socket, so 16 cores total per host. So that 4-node cluster, I've been able to push to 500.